Hi guys, welcome to lesson 2.2.2, day 2. We're going to continue working on transformations of lines today, and before that we're going to do a little bit of review just so this stuff stays fresh, and then we will get to writing the equation of a line given a graph. Alright, so the first thing we're going to review is using factoring to solve an equation, a quadratic equation to be specific. So this is where we will do that box and diamond method. All right, once you have your box, I'll draw my diamond too. Remember, you take the first term and you put it in the top left corner, and then you take your third term and you put it in the bottom right corner. All right, and now we can go ahead and switch to the diamond. Remember that the top of the diamond should be the first term times the third term. So 20 times x squared is going to give us a 20x squared. And then on the bottom will be the middle term. This actually should say 12x. That is my bad. Let's go ahead and try to make an attempt at correcting that here. All right. So now we can go ahead and play the game where we say, okay, well, what two numbers multiply to make 20? That's dot for multiplying, and add to make 12. Well, if we just think of some numbers that multiply to make 20, we can say, oh, well, 5 and 4 multiply to make 20, but do they add to make 12? They don't. So we cannot use 5 and 4. The next we can try are 10 and 2. Right? 10 times 2 equals 20, and 10 plus 2 equals 12, so those do work. So we can say, okay, well, 10x and 2x will fill in our diamond. Okay, and then we use those terms to fill in the rest of our box. And from there, we can go ahead and now fill out the outside of the box. So what times what equals x squared? X times x. And then here, x times what equals 10x? It's going to be 10. And here, x times 2 is what's going to get us to 2x. All right, so now we can say that our factoring form of this equation is going to be x plus 2 times x plus 10. However, please remember that when we're solving by factoring, we don't just stop after factoring. We have to go that extra step and use zero product property to actually solve these, right? So x plus 2 equals 0, x plus 10 equals 0. And when you solve this equation, you get -2 for an answer. And when you solve this equation, you get -10 as an answer, right? This one we had to add 2 to both sides. This one we had to subtract 10 from both sides. All right, and that is how you solve by factoring. Okay, so this one, I keep bringing this back because people always forget how to do it, and I think some people might even still struggle with it, so we'll keep working on it. If I ask you to solve an equation for y, that means we need to do whatever it takes to get my y term by itself. So a good first move here would be to add 4x to both sides, because that's going to help us in our journey to isolate the y term on this side of the equal sign. Okay, so this cancels, and we have then 5y on the left, and on the right we have 18 plus 4x. We cannot combine these two to equal 22 because they're not like terms, right? One has an x and one doesn't, so we just leave them separate. Okay, and then the last step we're going to do to get y completely alone is divide both sides by 5, because that is going to finally get y completely by itself. All right, so our answer then is this. And you want to actually do the division. If you can't do the division, you can just leave it as a fraction. And this is my final answer. All right, so the thing that we want to focus on for today's lesson then is how to write the equation of a linear graph given the graph itself. Okay, so recall that the parent function looks like this, y equals x, and then this right here is the graphing form. So when it comes to writing the equation based on a graph, we have to look at the picture and find two nice points to base our equation off of. The nice thing about linear graphs is that we can really use any points on the graph and it would work the same. So let's use this one, and then the next nice point after that is this one. All right, so what we want to do first is find the slope. Okay, because remember the slope is the a value. And in order to find the slope, it's our rise over run, right? So it's our vertical change to get from one point to the other, as well as the horizontal change. So in order to go from this point to this point, we had to move down 1, right? Down 1. And we had to move to the right by 1, 2, 3, 4. So on my slope, because we moved down 1, it's going to be a -1 for my rise. And it's the right 4 means it's going to be a +4 for my run. Now, I know that a lot of times when we talk about horizontal in this unit, we do like opposite signs, but for slope, that does not apply. Okay, that just applies to my h and k, not the slope. So this tells me my a value. So now that we have the slope, we need to get our h and k. The nice thing about this is that we really could use any point we want. So I'm going to go ahead and use this one. Okay, the coordinates of that point are -4, comma, this lands at -3. So -4, -3. Okay, we can use this to find our h and k, right? We have typically, opposite of h, comma, k. So this tells me that my h must be the opposite of -4, which is 4. And then this tells me that k must be -3, because k is just as is. So now I have all the information I need to write my equation. It's going to be y equals, notice how the a value comes first, so -1/4. And then we get our x and our h in here. My h is +4, so I'll do +4. And then my k is -3, so I'll do -3. And we are done with that equation. All right, one more here. So like we said in the last problem, our first step is to pick 2 nice points. I'm going to go ahead and pick this one, and then the next one is this one. So once again, we're going to start by finding our slope. Our slope is rise over run. So from this first point to the next point, we moved up 1. So it's a +1 on the top. And then we move to the right 1. So it's going to be a +1 on the bottom as well. Now that can just simplify to 1. And again, that's our a value. All right, so now that we've done that, we need to go ahead and find our h and k. So we can use a point for this. I'm going to go ahead and use the point 3, -2. And again, you really could use any, but I've just chosen to use this one. And so the coordinates of that one are, again, 3, -2, since that's where they trace back to on the axes. And so let's use that to find our h and k. So this 3 tells us that our h is -3, because it's always the opposite. And the 2 tells us that the k, well, sorry, -2, is going to be -2. So now we're ready to write the equation. We have y equals the slope. Okay, so if our slope or a value is just 1, remember that we don't actually have to write it if it's just 1, but I'm going to write it just so that we can see that it's there and that we found it. All right, my h is -3, so I'm going to put a -3 in here, and my k is -2, so I'm going to put my -2 on the outside, and I am done. Okay, and that is all for today.